So can I get a thumbs up from all the machine learning enthusiasts there? Hello and good evening to all. I'm Snigdha from ML4E, and here is another webinar by Machine Learning for Everyone and IT Rourkela. This club was formed this year with the motto to bring together everyone with the love for machine learning. For us, if you're a beginner or a newbie, this club believes that machine learning is for everyone. We are passionate by passion and driven by practicality. So today we bring you a webinar on artificial intelligence in production by Mahesh Narasimha sir, who is presently working as a senior product manager at MLAI Products and has worked for 10 years with Cognizant. He also has 15 plus years of industry experience. Now I would like to invite our faculty advisor, Professor Manish Okhare, to speak a few words. Hope you all enjoy today's webinar.
Yeah, thank you, Snigdha. It's always a pleasure to be associated with this particular group. So this machine learning for all or machine learning for everyone is a active group at NIT Rourkela, which has become more active sort once the lockdown has started, and we have been inviting reputed industrial as well as academicians to host as well as guide our students. So in the today's series, we have Mahesh Narasimhan with us. As you just introduced, he is one of the persons who's doing a product related work with respect to machine learning. So which I don't think even I have the expertise. So to be very frank, so I would be the one who would be the most glued to my screen now, and I wish all the students also do that so that we could bring. He would be a good interface for us to bridge the gap between the industry and the academia. So I think I'll establish a good rapport with him, because one thing that I could see similar is we have similar names, and he's Mahesh and I am Manish. So maybe I am an academician and he's an industrial guy. So I hope we can bridge this gap and chop a few letters which are dissimilar in our words. So with that, I think I welcome him again, and I want, being a teacher, it's always a pleasure to have students or audience listening to us. However, because my expertise is less in this area, I directly hand over this scope to Mahesh, so that we'll get more insights into the artificial learning, especially with regards to products. So with this, I'll end my talk, and we welcome again Mahesh, and we hope to not only via this webinar, we hope to keep in touch with you after this also. Okay. With this, I think the stage is back to him. Thank you very much, Nigda.
Sure. Thanks both Snigdha and the professor. Thanks very much actually for giving me this opportunity. I just connected with professor just before Snigdha and others joined. But yeah, so we can make this session interactive. I absolutely have no issues. You don't have to call me sir. You can call me Mahesh. So I have a presentation to go through, where I'll first just a little bit explain on what we are as a company, what we are doing, specifically around artificial intelligence, and what how to go about building any product where you have artificial intelligence married to the product, right? And how we have done it. So the experience comes out of launching a product that is in market, that is being used by customers. So I put together a few so that it could help the students understand the process of going about getting to know how a product could be built with AI. Let me know when you are able to see my screen. I hope you can, right? Okay. So you guys can see my screen, right? Snigdha or Mrityunjay, can one of you confirm? Yes. Before I go.
Yes, I.
Yes,
Yes,
sir,
I
you're
would.
visible.
You can. Okay, thank you. So this is what I do. So I think to give an introduction, Snigdha and the professor as well. So I'm a senior product manager at the AI Labs, Saama Technology. Saama Technology AI Labs is just a part of Saama. Previously, I worked at the intersection of products and life sciences. I mean, essentially on products at the intersection of life sciences and technology within Cognizant in various roles. So you can connect with me on LinkedIn. Just email me, or I have an active GitHub profile as well. Just so that you want to follow, or okay, so we'll have an interactive session, as I said. So I'll just go over some of the slides. It doesn't have to be monotonous. You can just stop me and then we can discuss. And I also have a final session on Q&A as well. So it can be either way. So just feel free to jump in. I don't like to be the one who's going to do the full talking. Okay. So we'll just go through, and then we'll pause for questions. So I'll specifically talk about the research labs that we have here before we jump into the details. So, we have, in India, we have offices in Pune and Chennai. Chennai is primarily the deep learning based labs. We also have offices at New Jersey, Bridgewater, California, and Switzerland, Basel. Just so that it just a small company, but the deep learning unit is is doing its kind of cutting edge research, and we are embedding that research into the product development. How we do it, we'll just see it going forward. So from the company, we have about 22 patents filed, and 6 have been approved, and there are 10 scientific papers that have been published. Uh, so you can, so specifically around artificial intelligence. So I'm just going through some of the papers that have been approved and published. So I'll just probably touch base on a couple of them. If this, if in case it you're inquisitive around what do these papers essentially mean, you can actually Google them, download, and then read, and then come back if there are any questions also. But at a high level, right? So we typically, the products that we build deal with life sciences, pharmaceuticals. So essentially, any research that we do, right, it aims at addressing the problems that the pharma companies faces, right? So I'll just probably touch base on two of these publications. So one is the PHI scrubber, which is essentially the patient data. So whenever you work with patient data, right? So there are restrictions around using patient identifiers, patient names, and patient address, phone number, kind of personal information around the patient, called as a PHI identifiers. So it's a deep learning in a deep learning based model. So what we have done is, the model typically looks in any data sets, and it scrubs the patient information, so that you work with an anonymous data set, irrespective of what the data set is. There are a few, it's kind of templatized, and you just have to pass in a few parameters to, to make it work. It's a deep learning based approach, and the paper is also published. The second one is, I'll just probably touch base on the BioBERT NLI. So BERT, as you might be aware, is a, it's an NLP based paper recently published by Google, and Google search uses BERT. So BioBERT is nothing but BERT trained on specifically around med analysis, medical terminologies on various publicly available data sets. So BioBERT is an engine that specifically would use you can use search or Q&A queries specifically around the medical terminologies, whereas BERT is kind of a broader representation. So that was one of the papers that is also published. So yeah, so we have a research team that typically looks into any recent publications, they and then works to improvise that, or they kind of see what the use case is, and then come up with the research ideas. Any questions before I move further? Okay. So the next one is the open source contribution, right? So this is where this is again our deep learning folks. They not only work on the libraries or the frameworks. We also actively contribute. So we have contributors across all the four: TensorFlow, PyTorch, Keras, and Pandas. You can see in the release. So this is the release notes of TensorFlow 2.1. You can see some of our folks being mentioned there in the contributor section. So if there are 100K developers, right? So there are about 10 folks who actually actively contribute to the framework. And we not only use, we also contribute to these framework. Okay, now let's jump into our main thing, which is how do we go about building a product that is that encompasses AI. Right? Any questions so far? Okay, so I'll go ahead. So when you look at the ecosystem, right? So AI is just only a part of the puzzle, right? So you have technology, you have context, you have the data, and then you have AI, which is essentially math and deep learning, and then you have the computing. So it's essentially the puzzle has to be right in there. It's not just AI is just one part of the puzzle. So for example, technology, there are technology components that are available today, but you need the right integration and the right environment to make the technology work for your use case, right? So it could be big data. For AI is more dependent on the data, right? So you need more data, you need ways to acquire data, right? So technology is one part. Context is, so at Saama we work with clinical trials, but there could be other domain based. Like you could work with finance, you could work with automobile, or you could work with aeronautical. So your context based subject matter is another part of the puzzle. Now the third one is data. So before you work on any of the AI use cases or think about it, you need to have access to the data, right? So many of the times, what even senior folks at the company, they come back saying that we need to um, have AI implemented on this domain, right? But without thinking how data looks like, or is the data clean, is the data available, or does it involve more effort in getting access to the data? So that's one part of the ecosystem as well. The next one is AI and deep learning. Obviously you need the subject matter experts, you need to know the frameworks, you need to know how you need to know the math behind AI. And the last one is the compute engine, right? So typically it is the cloud, but if you have an in-house data center, you need to have GPUs, because deep learning models are trained on GPUs, and then there is retraining. So all these encompasses into what is called as the big puzzle, right? So AI is just one part. You need to still have access to these. You need to have right folks involved to get to know each of these, so that you can start with putting together a use case for a product. Any questions? Okay. So next is so this is the research focus for Saama, right? So we do so our domain is clinical trials, right? On clinical trials, what do we focus on, right? So we focus on natural language understanding, the explainable AI. We will talk more about some of these, Bayesian deep learning and quantum computing simulation. So the papers that you see that have been published predominantly would be based on one of these focus areas. So we'll talk more about this, and getting into a few slides. Okay, before we jump in, I wanted to set some context. Right? I know many of the students are aware of what artificial intelligence is, and I've done a lot of online courses, as well as have the theoretical knowledge around artificial intelligence. But what I wanted to quickly stress is, right, let's do a quick comparison between you might have already seen the graph on the left side. So this is deep learning, which is a subset of machine learning, which is a subset of artificial intelligence, versus rules driven approach, right? So I'll pick a simple use case here. So you see that it's a simple rules driven use case, right? So you have a clinical trial. So clinical trial is nothing but any study, any clinical trial, nothing but anything that is conducted on a on a potential drug, right? So if a clinical trial has an outcome that is being that is approved without any adverse events, etc. So then that becomes a part of your drug. It's part of the drug making process. Okay. So what you see here is essentially a rules driven pattern, right? So you go, there is a priority study, and then there are, so you have a study. Let me try to explain. So you have a study, and then you have sites. Sites are nothing but the hospitals, and within sites you have doctors who are essentially the who are essentially the owners of creating what is called as a protocol. So any clinical trial runs on a protocol created by the doctors, and the hospitals conduct the study. Okay, this is how it happens. So what we are trying to say here is that there is a study, but there are so many rules that are even for a small use case like identifying a particular site has a particular hospital has done their work or not, involves a lot of rules and a lot of queries and follow-ups. Okay, even a simple use case like that. But if we have a deep learning based approach, right, it makes the system a little easier. Building the model depends on the data that we have, but too many rules, right, it makes the software system extremely complicated, and there are a lot of manual efforts that are involved, a lot of follow-ups, a lot of process steps that needs to be put in place, which could be avoided with a deep learning approach. Any questions again? If I'm too fast, please do stop me. If you don't understand anything, just raise up and let me know. Okay, so when to use deep learning, right? So you have a linearly separable variables, like you have your salt and pepper. Uh, if it's linearly separable, then you use any of the machine learning approaches, right? You use a classification model, or any SVM, or any of the standard machine learning based approaches, right? But when it comes to be a non-linear or cannot be linearly separable, only then you need to consider about going into how we use or how we predict such use cases, right? Only then we start thinking about deep learning based approaches. Okay, and when do we even think, right? When do we even think about deep learning? What are the use cases that you need to think when you start thinking about applying AI, applying deep learning, right? So typically, right, the low hanging fruit are anything that needs to be immediately picked up, right? Something like a process improvement and automation, anything. So don't immediately start with any of the mission critical applications, right? Like for example, in clinical trials, we call what is called as a serious adverse event, right? If a patient takes a drug, and if the patient is hospitalized, it is called it's some, and if the drug is not if a drug takes drug and is getting hospitalized, then it's a serious adverse event, right? Or if it leads to a death, it's a serious adverse event. So you don't use an AI immediately to start with such use cases, because it's kind of mission critical, and you don't start with that. Start with the low hanging fruit. So first is you need to build the trust within the within your team. Whenever you create an AI based product, because the team needs to know that the AI actually works for any of the tasks which they are already doing. Okay, so we'll discuss on what kind of tasks that can be picked up and how to go about it. Okay, which areas of AI to focus on, right? So first we saw how to pick up an what area to pick up on use case, not the mission critical. We pick up something that can be automated, something that is process driven. We pick up that use case. and then come to identify whether so here perception is mostly imaging. So imaging use cases are are little easier to use because we have a lot of lot of frameworks, lot of transfer learning capabilities that have come in, so we could very well use imaging is relatively easier. So anything that has to do with understanding, right? Like prediction. So that is little trickier. It is still doable, but it's little trickier. Anything with which reasons, right? Why it occurs. That's where it gets complicated. So when you start to just focus on the perception or the understanding. I mean, it's not that you cannot focus on reasoning. You can focus on the reasoning part, but it's slightly difficult and needs a lot more time and effort and a lot more iterations to build it. So applications in pharma, right? So typically within pharma, so there are various, it's a broader domain, right? So we typically there is drug discovery, you have trial planning, you have conduct and post market. Okay, so AI can be used across these phases. So you can see that can used in drug discovery or trial planning. So at Saama we have actually used it almost all the places, and essentially some of the deep learning that I'm talking about are actually in production used by some of our sponsors. Yeah, any questions? Sorry, I'm not checking the channel, but let me know if there is anyone who's new here with some questions and all. Okay. Okay, not yet. Okay, so how to approach an AI product, right? So first is business goals, right? So as I said previously, so you pick a use case to improve an existing product or a service, right? Where say for example, you have a lot of folks working on a manual repetitive tasks a number of times. That is your low hanging fruit because it gets you started. It builds a trust with the team who can actually support that whatever you are building actually will work, and then you can actually cascade it to a broader team within the organization. So typically you pick up anything that to automate tasks or processes, and when you do that, the next thing that you do is you articulate and arrive at the metric for that. Like you pick a use case and you say that to improve this process, you need 1, 2, 3 these KPIs. These are the ones that I'm going to look at when I'm going after I finished automating the process. So that's your starting point of getting to a business goal. Okay. The second area is the business process integration. So what it means is that so when you say AI to a team, right? So the team will not feel comfortable. You could have a backlash saying that are you trying to replace the humans in our team, or are you trying to move away from the manual effort the team is doing? So they need to first have the trust that whatever you are building is actually helping them, right? So whenever you are building an AI, you need to have a trust factor in the system, so that first is people believe that the AI actually works, and second is they have a say in whatever you are building. So that's what we call it as add human in the loop context and AI explainability. At least if you, I think you might know about AI explainability, which essentially is say if you do a prediction, how you arrived at the prediction, what are all the parameters and criteria that you considered, what are all the scores the model provided, what are all the weights the model used to arrive at that prediction. That actually gives the little bit of trust behind your prediction, and that will make the user comfortable. So that's the second thing, right? Because so you are changing something, you are starting with a goal, you are going to change something. The business should be aligned to whatever the change that that you set out to do. Third is data sourcing, right? Before you build anything, the most important thing is data, right? So AI is dependent on data. It is to start, you need data. For continuous learning, you need data. So you need to first identify the sources of data, and then also find ways to retrain the model on a continuous basis. So worst case, right? Like say for example, you don't have any data, and you have done a lot of research on acquiring the data, but you still don't have the data, but you know how it needs to be done, how to gather data. Then you build a small, a prototype or a tool to actually acquire that data, right? So that's the third one that we are talking about. So data sourcing is extremely important. So once you have these three, right, you are on the right track to actually get to a smaller prototype of a product that uses the AI. Obviously, this needs the deep learning model at place, but so model is a core part, right? But you need these things in place so that you can fix the model for the use case. So, any questions?
So there is a question from our chat. What is
Okay.
AlphaFold under drug discovery?
No, that's a part of the discovery phase here. It's a part of the drug discovery phase. So what we are doing is it's so you have different molecules of drug, right? So how do you know what combinations could work, right? So you could essentially build a model with all the known combinations and molecules that are available in the market, and then if a new drug comes in, you actually identify and say that okay, this is already in place, or this is not in place, or this could work, or this has the potential to be better. So you identify that it's part of the drug discovery. So obviously, general adversarial networks is what could be used during the drug discovery phase. So does that help? Okay, shall we proceed?
So there is another question.
Yeah.
Should an engineer from the branches not associated with CS need to learn ML?
No, not necessarily, right? So, um, like, so we'll talk about. See, obviously, the skill is required, but you can do, so there are a lot of open courses and other things that have come up, right? So you could do a course. See, the primary thing that companies are looking at. We'll talk about it later if you are fine with it, because uh, I have those things in mind to actually uh, you know to tell what is probably required. But the short answer is not necessarily. You could do all the online courses that you want. You could contribute to open source, and you could do sessions. You could have an active GitHub profile, and then you can reach out. So I don't see any reason why you cannot have. But you need to be strong on the fundamentals. So that can be done, without the CS degree also. Okay. Okay, I'll move on. Okay, so every product, right? So every product. So first we arrived at the business goal. We said that there is a change that's going to happen. And we added the human factor, which is important for an AI product. And then we said that okay, we need data and we need more data. Okay, now we have this, right? How do we scale, right? So you cannot just build a product and say that this is going to work. You need to build a product that accepts or that scales going forward, right? The product could accept. You cannot do a product for one use case and then immediately if something little bit changes, you cannot build another product. Right? So you need to build something that actually scales for the users, scales for the use case that you're in, right? So this is where the concept of teach cycle comes in. So what is the teach cycle, right? So the teach cycle is this, right? So you identify a use case, and once that use case is identified, then you have a data, right? So that data, it could be an uncleaned data, right? It doesn't have to be necessarily a clean data, right? When I say clean data, you remove all the all the junk and then you label it, right? So that's what is called as a ground truth. Okay, so ground truth is nothing but the actual proper labeled data that the algorithm needs to adapt. Okay, so you start with the use case, and once you firm up everything, then you go to the ground truth generation, which is essentially your labeled data set. And once you have that, then you go for the model development. You develop the model, and the most important thing is the accuracy validation, right? Then you do the accuracy validation, and then the human in loop and retraining. So this is where the human in loop that I talked about came in, right? So you do the accuracy, and then you check with the humans on some of the parts that the machine is getting it incorrect, right? The user will have a say on each, try to have a way so that the user can have a say on the predictions that the model has generated, so that the user actually feels that the model is trying to generate something that is useful for him, and the user also get customized to the product and the tool in a way so that it's easier for him when you actually implement in a large scale. So this the entire thing, right? So this is a teach cycle, and this is the process which you will adapt every time you make a change to the product. So you don't change the core product. The core product remains the same, but whenever you want the model to learn something new, you follow the same thing, right? So say, assume that, I'll give you an example. Assume that you have so this is exactly what happens in the autonomous vehicle also today, right? The autopilot, the autopilot example. So you can, uh, the machine learns continuously, and how it learns based on how the human interacts with it, and it gets retrained. Okay, so this process can be fitted anywhere in the product, right? So at Saama, right, we have actually a number of products, but essentially everything follows the same pattern, which is a teach cycle, right? So we use the teach cycle. So if there is new data, if you want the model to learn something new, again, you start with the ground truth creation. Then the model still stays the same, but if you want to tweak the model, just tweak the model. Say a few hyperparameters or a few model configurations that needs to be done. You go ahead with that, and then substantiate the model with additional ground truth. Then do the accuracy again. Then check with human, and then do the retraining. So your core product remains the same, but your model goes through the process of teach cycle, and the model kind of becomes strengthened, right? So once you start with the ideation of the product, your model may not yield accuracy. You might get like 40% accuracy or 50% accuracy, right? Which is still okay to start with. Okay, but once you get to the users will say that, hey, the 40% is right, but the rest of the 60%, they would be able to provide feedback saying what is wrong and what is right. So you take that and again you retrain the model. Now your accuracy becomes 60%, right? And then it slowly increases. But once you go to the production as well, you can still, beyond production as well, you still have the same cycle of retraining the model, and then getting the human in loop involved and retraining the model. So this way, that having the teach cycle, it scales the entire product life cycle of an AI product. Any other questions? Okay, so next is, so we saw about what is teach cycle, and now we'll see about how to approach building of a product, right? How do you build an AI product? So we saw earlier we saw just a recap, right? So we saw business goals, we saw the how the process, how the change needs to happen, we saw how data needs to be sourced, and then we read about teach cycle. Now comes the core part, right? So first is a discovery phase, right? So you build something that the user needs. You don't force an AI into any teams or any organization, right? So you gather the user needs, talk to him on what his current problem is, how his repetitive, what is he trying to automate, who are all the stakeholders who are trying to, who are doing a lot of manual efforts. Okay, so that is the thing that is a part of discovery, right? So you identify that first. That's your first goal, right? So you build a product for the user needs, where the user is struggling to find an automated way to do. Okay, and you don't force AI into any of the team or product or organization. Okay, so second goal is the scalable design, which we talked about on previous screen, right? So you start with a teach cycle, you build the human in loop, and then once you have the human in loop, you build a low fidelity design, right? This could be an UI, okay, or this could be even as simple as an HTML prototype or an HTML UI screens, okay. So that's the low fidelity design, right? So you use that design because that's where it's easier to get the feedback from the uh, you know uh, from the user, right? So once you identify the human in loop, like what is the feedback the user needs to give, just go for the low fidelity design and then execute it. So this once you execute it, then you have your third goal, which is the right metrics, right? See, obviously you have model accuracy, you have a lot of metrics for the model, but typically what the user cares about, right? It's just the these values, the true positive, true negative, false positive, and false negative. Okay, I'm trying to explain these things. So this is what the model, this is what the typically the users aim at, right? The users aim at increasing the true positive, right? The true positive is something that a model predicts something, and if it had to be done by the user in a manual way, the user predicts the user has the same value. So essentially both the user and the model matches, right? That's the true positive, and that is what you aim to increase. Okay, that's it. Your goal should be to improve the true positives. Okay, but it cannot, right? So your model is not and it's not a rule, it's not rule driven, it's not manual, right? So you will have false positives. So false positives is what the model predicts correctly, but the model predicts, but the user says that it is wrong. Okay, so manually the user says that it is wrong. And false negative is the opposite, where the user says it is right, but you don't have any predictions in the model. Okay, and true negative is both don't agree. The model doesn't you provide a prediction, and neither the user doesn't say anything. So true positive, yes, you need to increase, but which one to reduce, right? False positive or false negative, how to improve that actually depends upon your use case, right? So some use cases might require the false positives to be there, right? So that they can, the users can review the false positives and then improve the model. But some use cases you cannot have false positives, right? So it really depends upon apart from true positives, it really depends upon the use case as to if you are okay with false positives or not okay with false positives or false negatives. Okay, so now goal 2 and goal 3, right? You just iterate on and on and on until you have a success metric, until you agree with the user that okay, this is the right percentage that you want to be in at the start, and this is where we are. So that's the essential outcome. So what we learned here is few things, right? You start small, building the low fidelity prototype, and you design and execute. You build the human in loop. You augment the data with retraining. You measure and iterate. Okay, this is the a short snapshot on building a product efficiently. So I'll pause here for questions.
Yeah, I would like to ask one question. So, with the limitations of use cases, the performance also gets limited. Like, we cannot expect the certain amount of accuracy and certain amount of performance in every data set or every use case. So, at which point can we get to know that, yeah, we have got the enough amount of performance or enough amount of accuracy, we need to stop here?
No, can you repeat it? I think you're too fast. If you can be a little bit slow. That's it.
Sorry, sir. So actually, I meant in some of the cases, we might get accuracy up to 98 and 99%, but in another cases, even
Mhm.
getting 70 to 80% accuracy is really tough stack. Like it depends upon the use cases and the problem statement
Correct.
that we are tackling.
Correct.
So yeah, so at which point can we know, like, can we get assured that Yeah, we have
So
already achieved the certain amount of accuracy, certain amount of performance.
yeah, so that is what you
Like, how
decide
can we
initially,
measure
right?
ourselves that?
Yeah, good. Okay, I got the question. I got the question. Okay. So that is what you decide initially, right? When you pick a use case, when you try to automate a task or a process, you first arrive at the metric or KPI and then say that you will need 75% accuracy, 80% accuracy, and that is good for the process. Okay. And if it is 80% accuracy, it's still fine. And you can possibly articulate and say that it will at the best case you can have 80% accuracy, and we can slowly improve on iteration. Or you can say that there will be 80% accuracy with additional false positives, which needs to be manually reviewed by the human in loop, which we talked about. So essentially you agreed at the start, for each and every use case. So for example, right, so if you have two teach cycles, for one teach cycle you might say that, hey, I've trained the model comes to about 80% accuracy. There could be false positives, okay, which is okay, which should be acceptable, just before you execute the teach cycle. The second teach cycle, you could say that the model is 90% accurate, or above 85% accurate, and there will not be any false positives, but there could be false negatives, okay. So you could say that it's essentially what you agree with the user. You cannot say that the model will be 100% accurate unless it's obviously rule driven. Does that help answer the question?
Yes, sir.
Can I proceed?
Yes, sir. You can.
Okay, so the next is very important, right? So we saw how to build an AI product. What is the approach? See, this is not the only approach, obviously. So this is the approach which have worked for us. Okay, so that's the that's what we wanted to share. Because it's something which we have in production, which we are using internally. So it could work for it worked for us. So it could work for other teams also. Okay. So what we have seen on AI products is that, as I already explained, right? See, the trust factor of a prediction, that has to resonate with the user, with everyone, so that only then they can vouch for the product, that it's an AI driven product. The prediction is this, and there is a workflow, and everything kind of falls in place. Right? So that explainability factor is very important. So we'll see how it is done, and how you go about doing it in the design as well. Okay, so you can add, I mean, obviously you might be familiar with explainability, but there is explainability in the to the model, but there is explainability to design, which we'll talk about. So obviously there's a need for explainable AI, because every field that you take, right, be it finance, marketing, security, or logistics, whatever prediction that you do, whatever model that you do, there'll be a lot of questions, right, from people who don't understand AI, obviously, or from senior folks also, right? Like, why did you do that? Why not something else? How did you arrive at this prediction? This doesn't sound logical. I need to know, what are all the, what are all the parameters that you considered for arriving at this prediction? You can provide it for one, but it comes repeatedly for each and every prediction. Then it's a more of a manual task, right? So you need to build this in the product to tell the user that, hey, I have a product, I have provided you a prediction. That prediction is traceable. That is, this is the data source, and from data source it goes here to the model, and from the model it goes here, and then you arrive at this prediction. These are all the scores. These are all the parameters that the model considered, and these are all the scores that the model had took, so that the next time the model is retrained, the user is able to understand, and he can, while providing the responses in human in loop, he can actually tweak and then say that, hey, he can verify and have the confidence and trust the next time he sees the prediction. Okay, so that's why every product that is getting built, right, it is absolutely essential to have this explainable AI as a part of the product. So if you just have an AI with a black box, then it actually creates a lot of confusion with the users, right? So every user, right, you build an AI product, starting with a business owner, you build build a product to, say, a finance company, right? Starting with the business owner to the customer support to IT, everyone will reach out, and there'll be a lot of operational related questions like, how do I answer this? How the AI works. So if something is incorrect, you'll not be able to understand. So instead of creating confusion, that's what is called as a black box AI. So you eliminate that, right? So you eliminate that, and then you come with an explainable AI. So the first part here is a black box AI, which says that you have data, you build the model, deep learning model or whatever model it is, and then you build an AI product. Okay, then you either provide a decision or a recommendation. And obviously, why did you do that? Why did you not do that? Etc. The question happens. Then comes the explainable AI part, for which there is data. Then we provide an explanation to the prediction, right? That's the explainable AI product. You have a decision or an explanation. The human in loop provides the feedback, and the feedback again goes to the AI. Okay, so this clearly states that I understand why this happened. If the model prediction has gone wrong or it's right, what are the parameters that it considered to make it right? Okay, and then I know why it fails or why it succeeds, and I understand, so I trust the model. Okay, so this is the sort of behavior that will bring in the confidence with the users and have the trust in the product. Okay, so you start doing this with the first and the foremost iteration. Then that you'll have a lot of users who will be willing to use the product and will be onboarded. So, I mean, obviously, wrong decisions are costly. So, AI misclassifying a cancer patient as non-cancer patient, or autonomous car crashes, right, which we have read about a lot of times. So that's the why that's the reason why we actually need the explainability factor everything. And obviously, there are laws against discrimination, like gender, race, and disability. So once you have the explainability factor, this takes into account everything, because you provide a traceability for the prediction, right? So that actually takes the it's completely transparent and takes the guesswork out of the prediction. So I'll go for the explainability by design, and then I'll pass for questions. Okay. So what we saw is explainability for the model, right? So you build the model and you provide explainability for the model to trace back all the predictions. Okay. Now the product itself could very well have the explainability built in, right? So for training the model and so model debugging, etc. You build say, for example, for training the model, right? You build an UI and then have the users do the training automatically. You provide a visualization saying that, hey, this is your first iteration of the model. Your accuracy is this. The second version accuracy is this. This is the total number of records that was processed, and the total number of false positives, false negatives, true positives, and true negatives. So similarly, you do it for iteration to iteration, right? So you do it for the model. Then you do it for testing, right? For model evaluation and testing. Then you do it for deploy. Deploy is model launch and sign up. So how do you launch a model, right? So you have a model on dev. So from dev you move to UAT and then you move to prod. Okay. So you have a user interface built in so that it can it shows the trace of how a model is launched from dev to production, right? And then obviously we talked about product, which is the explainable decisions, right? So that's the decisions. We talked about the predictions. Okay. Then you do so you compare the models. Right? You build an A/B test comparison between the models, right? You have few users, work on the iteration 2, and few users work on iteration 1, and then you compare the results, right? So and similarly for monitoring, how do you monitor the performance of the model, right? What are the parameters that you choose to monitor the performance of the model? Show it to the user, in terms, if it is available in terms of the UI, just show it in terms of the UI. Just build a separate, so similar to a so you have a product, so build a user persona for a data scientist or a product owner or anyone who could essentially have access to access to see how the model is performing over time, how many predictions it has provided on the first iteration, how many on the second iteration, was it substantiated with the ground truth, does the human in loop feedback improve the iteration of the model. So you show that it doesn't have to be on the very first iteration of the product, but when you design the product, you think about it, put it in the roadmap, and iterate on it. Yeah, any questions? So Lime and Shap, so these are some of the Python libraries out there that actually provides AI explainability. So obviously there are more work, and you will obviously see much more coming in that provides more explainability to the model, to the decisions that the model takes. Okay, so I'm actually done with the presentation, but I'm open to any questions now. Feel free to pitch in with any questions. It doesn't have to be on the product side as well. If you have any other questions or anything else that you want to clarify, I'll try my best to answer, but go ahead.
Okay, sir. So is there any new innovations involved in AI production?
So kind of, I mean, new innovation in the sense, where it depends on how you term innovation, right? Like say for
This
example,
question,
I'll give you, yeah, go ahead, sorry.
yeah, this question is followed by another question. Like he asked, is there any focus on developing new models, or is the focus mainly put on applications?
No, see, your model is the core, right? There are no questions about it. So your deep learning model is the core of any product, right? But for the deep learning model to be used, you need to build a framework around your model, right? So if I build a deep learning model and I give the predictions to any user, right? The immediate response to the majority of the users would be, how do I trust this, right? So how do I trust this? How did you arrive at the prediction, right? How can you show it? How do I know each and every line of it, and how do I make it repeated, etc., right? So there'll be a lot of questions. And what we have seen, right? So this is based on the experience. What we have seen is just the plain model given to the users, right? Majority of the case it doesn't work. So they'll come back with a lot of questions. They'll obviously the trust factor that needs to be improved, and that's why the obviously the short answer is the core to the product is the model, but you need to build the outer frameworks for the model to be used, to be trusted by users. And the first question, right? Innovation. I think I'll need a little bit of clarity around what is actually term innovation. So, like say for example, at Saama, right? We build any like the life sciences product that we build. So we have built the explainability AI factor into it, right? And we have not seen any life sciences product with an explainability AI up and until then in the market. Okay, so that could also be termed as an innovation. So it really depends on what innovation is in your perspective.
Okay, so another question from the chat. Can you tell me more about Lime and also about SAP?
Yeah, that actually you can Google it. So I think it's pretty much it's a library, right? So what it does, you can Google it. It's open source. You could try to there's a a GitHub for the for both the packages. Just install it, and you will be able to do it. You can self explore it. So it's essentially a traceability. So when I say traceability is, so you do a prediction. So and you built in as a part of your model. Okay, so when you do a prediction, it will tell you exactly what path it took to arrive at the prediction. So what you typically do is you take that path out and then build it as a say for example a bar chart or something, right? So that the user will say that, hey, this is your prediction, and the model has taken this path to actually arrive at the prediction. So it's visible to the user, and it tells the user knows that, okay, so here is what the like say for example, right? So I gave an example of a clinical trial, right, where there was a site, or it is a hospital and a doctor and a protocol, right? So if I provide a prediction, I would say provide right. I arrived at this prediction, and where the hospital, the hospital was like in a, I would say out of one, the hospital was giving me a weight of 0.6, and the doctor was giving me a weight of zero point 0.2, and the other one was 0.1. So the overall weight is this much. That's why I qualified this for a prediction. So that's the scores, weights, and other things that arrive in the traceability. That's what your Lyman Sharp provides.
Yeah, hope it has answered Gokul's question. Okay.
Yeah, let me know if there are any questions. I'm open to any other questions as well. It doesn't have to be the product, as I said. Anything else from the professor? I hope it was.
Sir, there is a question from the chat. Okay, sir, it is observed that recommender systems are likely to suffer from popularity bias. What are the ways to prevent this?
Recommender systems are to popularity bias. Okay, and
What are the ways to prevent this?
I don't know, seriously. I understand your question though, but I don't know. I don't have an answer at this point, seriously. But yeah, see, I can see ways to preventing that is it might be less, right? But if it is popular, then obviously there is so there are a lot of users who are actually using it, and in recommender systems specifically, you might see that over a period of time, it's not only over a period of time. There are hot starts and cold starts, right? So it depends on actually the system. But if you are specifically talking about, like, say for example, Amazon or Netflix kind of a recommender system, I don't have.